Hey students, this is lesson 6.3. In this lesson, we're going to learn how to solve systems of equations using a process called elimination, and either by addition or subtraction. I'll show you how to do that in a little bit here. Go ahead and do the review here. I'll check back. All right, so the idea here is that we're going to somehow combine these two equations so that we end up with an equation that only has one variable in it. And the idea behind it is this: let's say A is equal to B and C is equal to D. Then it would also be true that A plus C is equal to B plus D. And that's just a form of the addition property of equality. So on this problem right here, what I'm going to do, since you might notice right here that we have a minus 4y in this one and a 4y in this one. So if I add these two equations, these two expressions together, I can combine terms, the 3x and the 5x, and make that 8x. And now if I add 4y and then subtract 4y, so 4y plus negative 4y is equal to 0y. So I really get this now. And then if I add the negative 22 plus 38, I get positive 16. And notice that we have 0 times y, which is just 0. So I really have this equation now, 8x equals 16. So I've eliminated the y variable. And I now have a simple equation. I can just divide both sides by 8, and I get x equals 2. Now that I know that x is equal to 2, I can take either equation and substitute 2 in for the x. So I'm going to use the first equation, 3 times x plus 4 times y. And notice I've substituted my value of x, which is 2, for the variable x in the equation. And then I'm just going to simplify it and solve it for y. And to do that, I'm going to subtract 6 from both sides, so I get 4y equals negative 22 minus 6, which is negative 28. And then I'm just going to divide negative 28 by 4. And I get y equals negative 7. Now the last step you probably want to do is check it in the other equation, make sure it works. So I'm going to substitute 2 for x in the second equation. And I'm going to substitute negative 7 for y. And I just want to make sure that that equals 38. And I get 10 minus negative 28 or plus 28 is equal to 38, and that's true. So I'm good. Go ahead, you try that. All right. Sometimes we might want to subtract the equations to eliminate a variable, and that happens when you have like both, like say 3y in one equation and 3y in the other equation. When you subtract 3y from 3y, you get 0. So let's set up an equation here. Concession stand sold a total of 138 small and large popcorns. Let's let x equal the number of small popcorns, and y can be the number of large popcorns that we sell. It says we sold a total of 138 large and small popcorns. So that tells me that x plus y equals 138. And then the second part says a small popcorn costs $2.50, a large popcorn costs $4. The total popcorn sales were $466.50. So that means if I take $2.50 times the number of small popcorns plus $4 times the number of large popcorns, I should get the totals spent on popcorn sales, which is $466.50. Now, if I want to subtract to eliminate a variable, I need my coefficients to be exactly the same. And I can get that by using the multiplication of property of equality here. If I multiply everything on the top by 4, now you could have multiplied everything on the top by 250 also. I have to multiply both sides by 4. I get a new equation that I'm going to just write down here. I get 4x plus 4y using the distributive property equals 138 times 4, which is 552. Now, with this set of equations, I have the exact same coefficient right there, 4 and 4. If I subtract these two equations, and actually I'm going to go ahead and subtract this equation from this one. That way I'll get a positive coefficient. 4 minus 250 is 150. X, and 4y minus 4y is 0y, which is just 0. And then I just have to do 552 minus 46650. And so I'm going to divide both sides by 150. So 8550 divided by 150 is 57, which means I sold 57 small popcorns. Now the number of large popcorns, I can just use one of my equations to find that. Remember, x plus y equals 138. So, and we just found out that x is 57. So if we subtract 57 from 138, we get y equals 81. And then you might also want to check that by making sure that 57 times 250 plus 81 times $4 equals 466.50. All right, what is the solution to this system? Use elimination. So you might notice in this system that we have no coefficients that are either the same or opposites. So what we need is something either the same or opposites, and I like to create equations that have opposite coefficients because then we can just add the two equations and eliminate that way. If we multiply this bottom equation by 3, we end up with this equation, 9x minus 12y equals 51. And notice that that coefficient of y is minus 12 there. And in the top equation, the coefficient is positive 12. Now, if I add these two together, I'll eliminate the y. So negative 2 plus 9 is 7x. And negative 30 plus 51 is 21. Divide both sides by 7, and I get x equals 3. Using the first equation to find y, I'm going to substitute 3 for x. And so that's negative 6 plus 12y equals negative 30. Add 6 to both sides, and I get 12y equals negative 24. Divide both sides by 12, and I get y equals negative 2. Now let's just check to make sure that works. So I should be able to take 3 times my value for x, which is 3, minus 4 times my value for y, which is negative 2, and that should equal 17. And that's 9 minus negative 8, or 9 plus 8, which is 17. So that works. All right, you try that. Let me show you one more way to use elimination. Sometimes you need to multiply both equations to get something, at least to avoid using a decimal number or fraction. Notice here that I have 2 for a coefficient and 3 for a coefficient here. If I wanted my 2 to be a 3, I would need to multiply by 1.5, the top equation. It might be easier just to multiply both equations by something to eliminate. And one way you could always do this is multiply the top equation by the coefficient of the x value on the bottom equation. So multiply the top equation by 3. And then just multiply the bottom equation by the opposite of the coefficient of x in the top equation. So notice that was 2, so I'm going to use negative 2. And here's what happens. We end up with, for the top equation, 6x minus 9y equals negative 36. And for the bottom equation, we end up with negative 6x plus 4y equals negative 4. Now that I have opposite coefficients, I can add these two equations together. So I have negative 9 plus 4 is negative 5y equals negative 36 plus negative 4 is negative 40. Dividing both sides by negative 5 gives me y equals 8. And then to get x now, I'm just going to do 2x minus 3y, the top equation is negative 12. Substitute 8 for y. Solve that. And I get 2x equals 12, dividing both sides by 2 gives me x equals 6. And then the last thing I should do is check and make sure it works in the other equation. So 2 times 6 minus 3 times 8 should equal negative 12. And that's 12 minus 24, which equals negative 12, so I'm good. All right, you try that. All right, the last thing we're going to do is learn how to find the number of solutions. And to do that, we're just going to start the solving process. And what we're going to look for is either an identity equation, a false equation, or an equation we can solve, which would mean there's one solution. So to do that, what I'm thinking is let's multiply the bottom by negative 4. And that will give us negative 12x for coefficients, so we get negative 12x plus 8y equals negative 20. Now notice what happens when I add these, my top equation, which was this. And when I add that, I get 0x plus 0y equals 0. So essentially, I'm ending up getting 0 equals 0. And what that means is there's an infinite number of solutions, because I ended up with a true equation. Okay, go ahead and try that. All right, that's it for the lesson. Go ahead and do the lesson check, and we'll talk about it next time we meet in class.